Welcome to Spreadsheet Geek. In this video, we'll take a look at the XNPV function. This very unique function allows the user to calculate the net present value of a series of cash flows occurring at irregular intervals in time. We'll compare and contrast use of the XNPV function with the regular NPV function. This video was made using Microsoft Excel 2019. Let's do a simple comparison of net present value to X net present value just to see how the formulas differ. This is our investment project number 1. We'll discount these cash flows at a rate of 5% annually. These are our cash flows and dates laid out below. We'll pay out $10,000 at the beginning and another $2,000 at the end of year 1. At the end of years 2 and 3, we expect to receive the following cash flows of $6,000 and $14,000. If I were to calculate the net present value of these cash flows using the old net present value function, you enter the rate, and then you enter the values, but you omit the first value. And you have to add that initial cash outflow at the beginning. That results in a net present value of $5,631. Now, if I were to perform this same net present value evaluation using the XNPV function, it works like this. Unlike the net present value function, I include that first cash flow. But I first enter the rate, then the values, then the dates. And these dates and values do not have to be in chronological order. That yields the exact same answer of $5,631. So to recap, the net present value function calculates the present value of future cash flows, not the cash flow that occurred at time 0. And these cash flows must occur at equal intervals. These are all 1 year apart. And you must add in that first cash flow separately. The net present value function never asks for these dates over here in column A. So it's important to understand when you're using that function, it assumes that each of these cash flows will occur at the end of an equally spaced period. Now, if we compare and contrast that with the XNPV function, this does ask for dates as well as cash flows. And the neat thing about the XNPV function is that the cash flows and dates do not have to occur at regular intervals. In this example, they are, showing you that XNPV does everything NPV does and more. These dates can be in a jumbled order, but the first one does need to be at the beginning. And to prove that, I'm going to resort these by column B, largest to smallest. And you can see that that doesn't change our XNPV result. It does, however, change our net present value result because we have these positive cash flows at the beginning now, which have increased the net present value of that project. Let's consider a little more complex project. If your project was like this, with cash flows spaced at even intervals in time, use the net present value function. It'll have no trouble calculating your present value in situations like this. For a situation like this with very uneven and irregular cash flows, you want to use the X net present value function. If you don't, you'll have to calculate all of these discounted cash flows separately. Let's put this project example in a table and compare the manual calculation to the X net present value function. Here's that investment project 2 in table format. I'm going to use the same discount rate of 5%. Here's my dates. I've added one column here for elapsed days. So June 8th, 2021 is 158 days after the first day, and so on down the line. These are my cash flows. This is my initial outflow of $10,000, and we have another outflow at the end of this project. And by the way, in this elapsed days column, I'm simply subtracting this date from this date in this formula. So that's my formula right down the line. You can add and subtract dates from each other. Let's calculate all of these net present values of these different cash flows manually, and then we'll use the XNPV function to show how easy that is. This first cash flow at time 0 is going to simply equal negative 10,000. This second cash inflow of $1,000 158 days into the project will be calculated as follows. $1,000 divided by 1 plus our discount rate. I'm going to fix that value. And we'll take that to the exponent of our day count divided by 365. So I should be able to autofill those all the way down, and we get to a total project net present value of $4,815. Now we'll show how easy that is with the XNPV function. We'll enter the rate, the values, all of them including the first one, and all of the dates. Same answer. The XNPV function is a pretty powerful function for use with irregularly spaced future cash flows. You may not use it often, but it'll come in very handy when you need it. I hope you found the content of this video interesting and informative, and I hope you check out some of my other videos. Please consider hitting my subscribe button. Thanks for visiting Spreadsheet Geek.